Okay. Uh, Good morning, ladies and gentlemen. Uh, my name is Anta. I'm from the marketing team in APA based in Jakarta. I will be your moderator for today and your host. Welcome to our webinar for modernizations. Can get the most out of your existing flotation equipment. Basically, throughout this webinar, you will get to know more about how to bring measurable value across the key areas of your flotation process. Um, this webinar will take about an hour. A couple of side notes. Please note that this session will be recorded, and also please use the Q&A chat box if you have any questions during the presentation, and then we can answer those questions as best as we could. Next slide, Mick. So the agenda that we have today, typical flotation challenges, safety share, introduction, historical growth of the flotation machines, technology evolution, more out of ore, assessing the optimization strategy, customer cases, assessing tools, and also what about the sustainability benefits of these particular technologies. So move forward, Nick. And I'd like you to introduce you to our speaker, our expert, Michael Hughes, also known as Mick. He's the Senior Manager for Flotation Services. He's based in Australia, 27 plus years in the minerals processing industry, specializing in brownfields equipment upgrades in beneficiation and watering. Joined Metso back in 2008 and has held various positions across all aspects of the project lifecycle ever since. He also has a Master of Engineers, Mechanical at UTS, majored in optimization of design, manufacturing, and management. And on that note, let's move to the good stuff. Over to you, Mick.
Yeah, thanks, Antha. And it's a pleasure to be here to present on flotation technologies and improvements in design over the years. But first of all, I wanted to introduce the market area support team. As you see here, I'll start from the top left with Frank as the manager of the team, leading a team of 11. There's a couple of faces not here today. And then from the left, we have Steve Mansell, Abri Mulyadi, Benjamin Stack, and Phil Prosser. I'll point those names out at first. They're the people in the team that focus on flotation and also some other products. The others you see there would focus on other products. For those in Southeast Asia, Abri Mulyadi is your local representative, and he covers all aspects of beneficiation, dewatering, and hydro. So for any questions, sorry, I skipped a little. For any questions, this is your local market area team. Along with myself, we can support you on anything you need. So getting into it, so flotation. Current industry challenges that we're experiencing, and this is probably well known for many of you. Essentially, we're having larger throughputs, we're having decreasing ore grades, we have to meet stricter environmental regulations, we need to process our ore with less energy, we need more efficiency, the list goes on. And we're in this challenge with you, so here's some technologies that may be able to help you with that. But first of all, safety shed. As you're likely aware, a flotation cell is a confined space. Typically during a shutdown, the cells are emptied, cleaned, isolated, and then entered for inspection. Typically works occur in each of the shuts for maintenance. Sometimes Metso will come along and perform those maintenance inspections or perform the maintenance itself. And we follow the guidelines of the industry standards for safety along with the site-specific safety requirements. But not only is a float cell a confined space, but also in some circumstances, there's no access hatch on the side of the tank, and it can be considered to be working at heights if you were to access the cell from above using a ladder. So keep those items in mind when you're working in a float cell. It's certainly a confined space, if not also working at heights. And just ensure, and we always reiterate, before you enter the cell, just make sure, visually check that it is isolated, as you would when you're signing on to the isolation permit. So moving along, little history on flotation. It's been around for more than 100 years now. It is the key extractive unit process for recovering the valuable materials. Then for a long period, not a lot changed. It was typically very small cells over multiple stages, very many stages. In the 1970s, we saw a bit of a change where cells became larger with less stages. We would typically see 5 or 6 stages in a rougher scab circuit, whereas previously there'd be tons of stages. In the last 4 decades, though, we've seen flotation cells increase in size dramatically, and this graph demonstrates that. So from the 30s on to the around about 1970, there wasn't a huge change. We went from a couple of 100 litres to maybe 10 cubic metres. And then from 1970 onwards, we've gone from around 10 cubic metres to 1980 for 70 cubic metres, and to what we see today with installations of 630 cubic metres. Addressing the high throughput, low head grades requirements of today's market. So the slides there. So today we're going to focus on not only the collection zone, which is something we often focus on, which is the collection zone is where all the mixing is happening. That's often when we talk about our FloatForce mechanism. But we're also going to look at cases addressing the froth zone. So it's, as we know, it's important to, the mixing zone is where we typically measure our recovery. But if we're not then collecting those bubbles with those mineral-laden bubbles, then we're not essentially not recovering. Okay, so now an evolution of the mixing mechanism. As far back as the 70s, we had the multi-mix mechanism. Rotor and stator, you can see that there on the left-hand side. It's a full-length stator. And rotor, it was an industry standard for many, many years. We then transitioned through a free flow mechanism into what we call the FloatForce mechanism in 2006. There's a handful of installations of free flow in this market area. That's essentially a FloatForce stator with a multi-mix rotor. But then since 2006 onwards, FloatForce has been the industry standard. And then today I'll give a short presentation on FloatForce Plus, which has been released just recently, about a month or two back. So moving on to the talking more about the FloatForce mechanism. This is where we create the environment for the particle-bubble interaction. This is where we want those particles to attach to the bubbles, to stay on the bubbles, and to rise and flow over the top of the launder. The performance of the mechanism has a direct effect on the concentrator's operational profit, and it's likely the most important and focused on part of the flotation cell.
FloatForce stator assembly supports smaller stator wearing parts. Smaller parts and easy access minimize hauling and reduce time in confined space, easy and safe maintenance. The traditional stator is mounted to the tank bottom, resulting in wear on the tank bottom, which may lead to
So that's just a short video. It's an extract from a longer video showing the key difference between the multi-mix and the FloatForce. The FloatForce stator in this case is significantly shorter than the multi-mix. It focuses on the wear areas of the stator. So then essentially when you replace the stator, you're only replacing the parts that wear. The standard of FloatForce stator arrangement will outlast multiple wear parts in a typical application. So let's look at a case study here for FloatForce upgrade. This is a case study for a site in Queensland, Australia, Cannington. It's a lead zinc operation. The challenges they had and they put to us was they wanted to reduce their power consumption predominantly. But they also want to do that at no loss of metallurgical performance, and they expected us to actually do better. So our solution that we put forward, it's in a train of zinc rougher cells. There's 10 in the row. There's OK38 cells. We retrofitted the first 3 of those cells with FloatForce mechanisms. The results from that upgrade is we got a 17% power saving and a zinc to zinc final con of 0.4 to 4% increase, and then a lead to zinc final con of 0 to 0.3% increase. You can see in the graphs on the right, the red dotted vertical line is the point at which we did the upgrade, and then the trend before and after indicates the performance improvements. So this was considered to be a success with a very short payback period. Then moving on to the current day design, the FloatForce Plus. This is designed as a successor to FloatForce. It is a direct bolt-in replacement for FloatForce in cases where you already have FloatForce installed in your flotation cell. It can also then be retrofitted to other flotation cell designs. Say you had multi-mix, a traditional Odotech multi-mix design, that can be upgraded as well, same as it would be for a FloatForce upgrade. It could also be in RCS cells or Tyroliver cells or big room cells. We're quite happy to consider retrofitting any other vendors' flotation cells with our technologies. Those types of cases we would handle on a case-by-case basis, assess the design, the solution, and put forward the best solution for those needs. The FloatForce mechanism is designed to increase the metallurgical recovery. It boosts the pumping performance and reduces the energy consumption, which I'll demonstrate on a couple of slides from there in a case study. So the FloatForce Plus has been developed over many years. It was a long time in development before we put this into market. Many CFD simulations, we see just one of those here in this screenshot. It brings higher turbulence and higher kinetic energy, but also evenly distributes that turbulence throughout the tank, so providing a better performance overall. Now we go to a case study. So this is for a site in the Nordics. It's an E160 cells, 45 million tonne per hour concentrator, open pit copper mine. The challenges they had, and they worked together with us to use and prove the FloatForce mechanism. So they have parallel trains of E160 cells, and the approach that we took was to replace each of the first cells. So, and I say each, so we put a FloatForce Plus mechanism in train 1 and a new traditional FloatForce mechanism into train 2. And then we ran a series of tests analysing train 1 versus train 2, first cell of each, at different operational parameters. In this way, we're comparing new versus new, so we can eliminate any questions about a new FloatForce Plus versus a partially worn FloatForce. As we know, as the rotor and stator wears, the performance does drop off. So the results from that, we did see a decrease in power draw at all the rotor speeds that we looked at. We did see higher recovery at several, but let's say most of the operating conditions we looked at. But we also saw consistently higher copper recovery across the PSD. The next slide shows a few graphs, the results from that. On the left, we're looking at the power draw reduction at 3 different speeds. The mid speed in this case is the standard FloatForce speed. where we see marginally more than 5% power reduction, FloatForce Plus versus FloatForce. If we reduce the speed further for FloatForce Plus and still maintain metallurgical performance, we see around about 13% power draw reduction. If we happen to speed up the rotor more than we typically would for a FloatForce, that power draw reduction is still there, although not as significant as it would be for a low speed installation. Looking in the middle, we have FloatForce Plus versus FloatForce performance, copper recovery. There's 11 data points there, and 9 of those are indicating that FloatForce Plus outperformed FloatForce in those operating parameters. And on the right, we see red for FloatForce Plus versus black for FloatForce across different parts of the particle size distribution. Typically, we would expect that mechanical cells such as this perform well in middlings, and FloatForce Plus outperforms FloatForce in that case. But more interestingly, also outperforms in the fines and the pores, where other technologies are being introduced these days to address those parts of the PSD. Okay, so I wanted to preface that video with what it's all about. And sorry about that, it auto started and caught me out. So that's essentially demonstrating why you would want to replace your rotor and stator. And a lot of sites will run their rotors and stators to failure, typically. But we do know, and through test work, that as the rotor wears, and it typically wears in one zone, and same with the stator, as it wears, the performance drops off also. So we have a tabulated drawing with an indication of where you might see the wear, where you typically will see wear. And that tabulated drawing gives indications of the remaining polyurethane thickness, at which point you should be replacing it to then maintain, not only maintain good performance, but gives also a good indication that you may not get through to your next campaign from a mechanical or maintenance perspective also. So feel free to reach out if you'd like that sort of data from us. We have that available. Okay, now let's have a look at launders and crowders. A little bit of an evolution of the history or the types of launders we have. On the left, and apologies we don't have a image for this, but this is the internal and external launders. Try to picture the tank wall and the launder sitting either internal of that wall or external of that tank wall. They are pretty much a standard offering, especially the internal launders. With those, typically we'd have a crowder, the next image along. That crowder then directs the froth to the launder lip. In the middle there, we have radial launder arrangements, which is suitable in certain applications. And center launder upgrade, which seems to be a more popular selection, where we have a launder in the middle of the froth surface area. This is an upgrade to an internal launder arrangement where we put crowders on the tank wall and a booster cone in the center, and both of those direct the froth to the launder lip. And we also have spider crowder upgrades, and these are more about adding crowders into an existing center launder arrangement. And I'll give 2 case studies coming up for a center launder upgrade and a spider crowder upgrade, and demonstrate the benefits that were seen during those case studies. So some of the challenges we see down the bank of a typical flotation circuit. Recoveries at the head of the circuit might be good and strong, but as you go down the circuit, you might see that recoveries are poor, and in some cases, there's not even any bubbles floating over the lip. To overcome this, we need to design the launder arrangement down the bank suitable for the froth carry rate for that cell, not only just for one size fits all, but rather specifically for the application in that train. And it's important to keep in mind, if you're not recovering your bubbles, you're not recovering in that cell. Regardless of what happens in the mixing mechanism, it's important that those bubbles go over the lip. So the center launder upgrade, so everything in grey you see there is a standard internal launder flotation cell arrangement. The gold colour is the upgraded components. In the center, you have a booster cone, which is directing froth towards the center launder. The ring you see somewhat in the center of the froth surface area as well. And the gold booster crowder on the outside is also directing froth towards that center launder. In this part of the world, a lot of you might recognize that center launder as a donut launder. With this, we reduce froth surface area, obviously increases froth carry rate, but we also reduce transport distance, both equally important for that application. So now let's have a look at another case study for a center launder upgrade. This is in Constantia, where we retrofitted a series of cells. They had a problem with the back end of their circuit, where the froth recovery was poor, and it was largely due to a very large froth surface area and transport distance. These are E300 cells, again parallel trains, allowing for quite a good and argumentative case study. In that case, they had quite a large 33-metre froth surface area and a transport distance of 2.8 metres. We retrofitted with a center launder upgrade to give 18-metre froth surface area and reduced the transport distance down to 0.8. So you can see the reduction ratios are quite significant. So again, the results and the approach that we took, the execution, was to retrofit the last 3 cells in one train. We then compared that against the other train for one shut campaign or operational campaign, and then during the next shut, we then retrofitted the other train. So during that period when we had one train retrofitted with center launder upgrade, we did the performance evaluation. During that period, we saw a 0.7% copper recovery increase across those cells and a 1.4% moly recovery increase across those cells. And in this case, the customer was quite satisfied to have a payback period of less than 6 months across the project. I think we're not hearing volume there. Is it true? There we go. There you go. I think that speaks quite loudly and positively for the upgrade. This image we see here. Not only can we demonstrate the performance with the numbers I showed, but you can clearly see pulping and poor froth mobility on the left-hand side, and afterwards improved. So let's look at another type of upgrade here. This is the spider crowder upgrade. These are drop-in crowders, V-shaped and symmetrically positioned around the cell to get a froth surface area that's suitable for the froth carry rate required. Typically fits into a donut or center launder arrangement. With this crowder arrangement, you reduce the froth surface area, and you can then run a deeper froth. You can reduce the air into the cell and improve the recovery across the cell. So moving along then, we see another case study here. This one in Central America. This is for E630 cells, the largest of our installed cells. The challenges the customer had was poor froth recovery, and that was due to an unstable froth and a very shallow froth depth across these cells. They had stagnant areas, and there was pulping happening. And this is the last cells in the train. Typically, that's where the majority of the valuable material has already been recovered. So our solution was to install these spider crowders to one of these E630 cells, and those cells were already equipped with center launders. The results that we observed were that we could run the cell with a deeper froth depth, around 17% more. We could reduce the airflow rate. We also increased the froth carry rate significantly. Mass pull was increased, but more importantly, that was increased with an improvement in grade. So the recovery across this single trial cell was increased by nearly 13%. And to demonstrate the improvements there, you can see an image on the left. We have a video coming up after this, you can see again, similar to before. But on the left, pre-upgrade, you can see corners of the froth surface area where there's essentially no bubbles. You can see the pulp, the bubbles are not moving. On the right, you can see colour in the bubbles now. There's these minerals there, and they do move. I'll come along now and show the video. And let's get some sound of that. So the left again is the pre-upgrade solution design, and then on the right you can see the drop-in crowders and the improvements in not only the froth, so the froth mobility, but also what's contained in the froth. Now, in general, what does it mean for you? So you might say, well, what benefits will I get for FloatForce? Well, we just demonstrated what another customer got with a FloatForce upgrade or a froth management upgrade. But here you can scan the screen, you get this QR code, and which then directs you to our website, which has some calculators in it. You can assess whether FloatForce upgrade is good for you, for your needs, or maybe you need a froth management upgrade for your needs. Or if you're not sure, you can scan the center QR code there, where you can answer a series of questions, and we would recommend what might work for you. And that would just be an initial pass. From there, you would then contact the likes of myself or those others that I showed earlier on the screen. And we could then discuss an upgrade that might work for you, and we could even put forward some indicative pricing and a solution that what it might look like for consideration. So today we only looked at the mixing zone and froth collection zone upgrades. Next slide demonstrates the whole suite of upgrades that we do have for FloatForce, so for flotation. We can upgrade drives, air control, level control, dart valves, service platforms. Dart valves, I'll go back to, is something we often see actually when throughputs change and darts are either running consistently in a plus 80% range or minus 20% range. We do have opportunity to change the dart sizes and get that operating range back into a better portion of the range. We would like to see that in the 35 to 55% position. And if you're not sure what works for you, and at a glance, if you're looking at optimizing your production, we could offer the whole suite of upgrades there. Or if you want to reduce your costs, then those upgrades on the right would work for you. And likewise for the others. I won't go through all of them, except to say that you can scan that QR code again, and we can suggest options that might work for you, and we can explore that together. So then we come to Q&A.
Right. Thanks, Mick. So for those that are attending, if you have any questions, please put your questions in the Q&A box. Just looking at it now, I think we have two questions. One of them is, should we have issue on site? How we should start the discussion with Metso? Do we need test works, or what's the process, Mick?
It really depends on what the issues are. Yeah, if it's a metallurgical issue, feel free to contact us and we'll talk through what your challenges are. And then from there, we would develop a path. And one of the paths is test work. It may be that test work proves that you can do better with your circuit. And there may be reasons why your circuit's not working well. It could be one of these aspects that we demonstrated today. If it is, then we could then propose what changes are necessary. It may be as simple as some operational changes that we could suggest for you, which you could execute yourself. And our approach would be just to suggest what makes sense for you. It's not about trying to sell a Mercedes when you just need a Hyundai. It's about trying to do the best for yourself. So I say first step, yes, reach out to either myself or those others that I'll show in. Might as well put their faces on the screen now. There we go. So this is the summary of those I was showing earlier on. Frank is the leader of the team, or the others on the screen there.
Yeah. Okay. Hope that answers your question. We also have another question. With existing tank and system, how long is Metso Engineering to study for upgrades and submit proposal to customer?
Okay, so that can take a matter of weeks, or in some cases months. It really depends on what the requirements are and the challenges in getting to the bottom of understanding what the challenges are and the solution. So, okay. Yeah.
Next question would be, recovery is critical and goal for flotation. Based on experience that Metso has, what is the minimum increased recovery that can be returned into the investment?
I think I understand the question is about what recovery increase do you need to make it worthwhile doing the upgrade?
Yeah, something like that. I think it's talking about the minimum recovery increase to actually make the return on the investment.
Make it worthwhile. Yeah, that's something that would have to be calculated at the time, but based on experience, which is what the question was prefaced around, if you're getting a 1% increase, you're doing well. And above that, we have seen examples where we can do far better than 1. But even when it's only around 0.5% increase, we can see we can justify through return on investment that it's worthwhile going ahead.
Okay, hope that's
Yep.
answered the questions as well. We have another one. Very informative presentation. Thanks. Have the Oct square type cells been discontinued? What are the notable benefits of the tank type to the Oct type?
So did you say up type?
OK type, Oct type.
OK type, yeah. So OK type or the trough cells, they're not discontinued. We still do promote those. But the key difference is a tank cell does perform better. It doesn't sand as much in the corners, and you'll get better performance out of that. OK cells, well, we use less steel, so they are cheaper size for size. Both of them use the same rotors and stators. Launder configurations are better in tank cells. Look at trough type cells will still be around for the foreseeable future. I've heard nothing about those being discontinued, except to say that the DR cells, the legacy Metso range, DR cells are now discontinued. We'll continue to support any existing installation with any spares or any complete replacements if necessary. But we wouldn't be selling into a new plant DR cells.
Great. Next question. Would you recommend that crowders should be installed towards the back end of all rougher and scavenger circuits where mass flow of froth is always much lower than the front end?
Yes. Well, it's not necessarily always going to be the right solution, but predominantly it is, yes. Like the slide I was showing earlier, where you will pull, your mass pull at the head will be better than the tail all the time. And so the frost surface area should be designed to suit. So yeah, crowding is typically done in the last cell. If that's two cells at the same level on the last cell, then that's both cells get done. Important to note that if you crowd one cell at the same level, you must crowd the other as well. That's about the airflow and distribution. I hope that answers that question.
Okay. Next question. Does Metso offer deferral payment?
We can do LCS agreements. We can do performance-based agreements where it can be a sliding scale either way. You know, we need to benchmark and then prove the performance of the upgrade to then be, let's say, paid the value of the upgrade. Yeah, we can look at those types of options.
Okay, sounds good. It's a pretty good option. Okay, we have another question. If any other audiences wants to ask questions, keep them coming. We still have about 20 minutes to go. So the next question is, has Metso retrofitted a froth crowder into an older style Wemco mechanical cell where rotating paddles are used to be scrap products into launders before?
Yeah. Not personally. I've retrofitted a handful of FLS branded cells. I don't often see paddles still in use, and in flotation plants that I've been to that did have paddles, they've long been removed. I think I've only seen in 16 years with Metso, I think I've seen maybe 3 installations still with paddles, and been to hundreds of sites, so it's very rare. If you wanted to continue with the paddles, then that would be something we would consider keeping, but I think our first line of thought would be to remove the paddles. It's an outdated technology that essentially nobody promotes anymore.
Yeah.
But otherwise, yeah, it's certainly any flotation cell can be retrofitted. Because in the end, essentially, we remove the older technology and we put in the new, and what was remaining was essentially a tank.
All right.
Yeah.
Sounds good. Okay, from the audience, is there any other questions that you would like to post on the Q&A box? Let me just check. Okay. Any other questions from the audience? Okay, here we go. Does will Metso offer any performance guarantee for the upgrade proposed? I think that was a similar
Yeah,
question.
so we touched on
Just
that earlier, but yes, can we do it? Yeah, certainly we can. When we offer performance guarantees, that can be a portion of the project value, or they can be sort of rolled into what we call a life cycle services type arrangement. Both of those we can discuss in detail outside of this call. But if we're going down the path of performance guarantee, there will be test work involved, both before and after, and we would get our flotation experts to help develop what that test work campaign would look like in detail and come to an agreement on what that looks like and define it well before we would go ahead with that type of project. I can think of one in Southeast Asia that's currently undergoing, and a number of others that we have done in the past, and those that were shown on the case studies, they all came with performance guarantees. But certainly, yes, it's quite common that we give performance guarantees.
Sounds good. We have another question. Thanks for the interesting presentation. I missed the part where you can access the QR codes. Are they on your website? Which QR code? Is it the recommender, I think? Could you go back to that slide?
I can go back, yeah. But also, we're planning to share this slide set with the audience.
Yeah. We'll also share the slides and the recordings as well. Yeah.
I think this is the one that was being referred to.
These are the tools. Yep. I think this is the one. Basically some tools to help you make your decisions. Correct me if I'm wrong, Vic.
Yeah, that's correct. That's correct, yeah.
Sounds good. Any other questions from the audience? We still have 15 minutes to go, and we could accommodate your questions if there's still any. If not, maybe you could move to the last slide, Mick.
Sure.
Okay, so is there any other questions from the audience that you would like to ask directly to Mick during the session? Okay. If that's not the case, then here we have Mick's. Oh, we have another question. Hold on. How rude of me. Okay. In general, what froth carry rate value do you see the need for crowding and where recovery loss is significant?
Okay, it's more of a visual indication. So you'll see at the back end of your circuit where the bubbles are just not moving over the lip. They're basically stagnant. It's all about froth mobility. It's hard to give numbers off the top of my head, but we do have indicative ranges of froth carry rates that we can share with you that would be prompts to say, hey, you need to look at, sorry about that, you need to look at reassessing the froth surface area of your flotation cell. Don't have those on the top of my head, sorry, but you can certainly follow up with whoever was asking that question.
Yep, that was from Harrison Crab. And we could follow up with that question after this webinar as well. Okay. Any other questions from the audience? Interesting discussions happening. So feel free to shoot in the Q&A box. Okay. I'm not seeing anything coming through at the moment. Okay, in any case, any other additional any other additional things you want to convey, Mick?
No, just to say thank you for joining us and for listening to what we have to say about how we can improve your flotation circuit. And I welcome any questions that come forward and be happy to help.
Perfect. So, okay. Hold on. Yeah, okay. So any questions that you guys want to have, please you could reach out to me, to Mick, and then there's the contacts here. Oh, hold on. Will crowding improve flotation with clay-rich minerals? Mick, we have another question.
It's a lot more complicated to answer right now. Actually,
That's all right.
I'd have to take that one offline, I'd say.
Yeah. We will definitely note down your questions, and of course, we will get back to you as soon as we can. And then we'll get one of our experts to contact you in regards to your questions. But overall, thank you for attending this webinar. Hopefully, it gives you some pretty good insights on what Metso solutions and what we could help you to optimize your flotation performances. Here we have the contacts, Frank Soriano, we have Stephen Mansell, Paabri Mulyadi from based in Indo, and Benjamin Stack. And I'll give you a minute. If you have, please scan the QR codes to provide some feedbacks about this webinar, what went good, what went wrong, what could be better. And also, if you do have some specific topics that you would like to discuss with Mick, there's a field there in the QR code where you could specify what specifically you want to discuss, and then we will follow up with our experts here at Metso. And on that note, thank you for attending this webinar, and we will be having more in the future. And thank you for joining. Then have a good day. Thank you very much. Bye-bye.
Thank you.